All right, 12.4, piecing it together. So unfortunately, this was actually a pretty cool activity, but it involved like cutting stuff up and sort of like a puzzle. That's sort of what a piecewise function is. It's a puzzle of, in this case, we've got 5 different functions in both cases. And unfortunately, that activity just doesn't work with remote learning. So I'm going to show you how to do it. You'll need graph paper. If you don't have graph paper, which I don't know why you wouldn't have graph paper, you really should. You could do this on Desmos as well. So I would really recommend doing that, especially considering, this will be tested on this eventually. So yeah. All right, so if I'm looking at my first function, I've taken out graph paper and I've made my x and y axes here. And I'm going to call this f of x, and this is x. All right, my x and y. All right, so I'm looking at my first function here. The first piece starts at -10, ends at -5. And both of these dots, beginning and ending it, are going to be open because these are exclusive. I'm not including. They're not part of the domain. The function is y equals -5, so it's going to be a horizontal line like you've seen already. So first thing I'm going to do is I'm going to go to -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here. And then the function is y equals -5, so I'm going down to -5. 1, 2, 3, 4, 5. I'll put an open circle there because we're not including that point. All right, and it's continuing all the way to x equals -5. So -10, -9, -8, -7, -6, -5. And that'll also be an open circle because, as you can see, it's not included. So I'm going to connect those 2 points. That's the first piece of my function. All right, the next piece starts at -5 and includes it, right? Because we don't want there to be a hole in our graph. So we're going to include -5 for the next part, and that's going to be y equals x. So what I might want to do, right, if I have a function, right, I hear y equals x, that just means that y and x are the same thing. So here I see y is -5, so that also means that x is -5. So actually, if I'm looking at my axis, right, let me label this for you. -1, -2, -3, -4, -5, 1, -2, -3, 4, 5. This point is y equals -5 and x equals -5. So that point actually is going to be filled in because that's where the function is at that point. When x equals -4, y equals -4. When x equals -3, y equals -3. When x equals -2, y equals -2. When x equals -1, y equals -1. And the last part of this domain is 0, but that's going to be an open circle. So I'm going to put an open circle when x and y are both 0. Let me connect my dots. Great. Next part is y equals 1 when x is between 0 and 3. So I'm starting at 0 and it's inclusive. Maybe I should put this right here so it's easy to see on the video. Right. So y equals 1. I'll label my axes. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So I see that between 0 and 3, y is equal to 1. So starting at 0, y equals 3. I'm sorry. That's not true. Starting at 0, y is equal to 1. And it stays equal to 1 up until right here it gets to 3. So I'm going to put an open circle at 3 because it's not inclusive there. Then I'll connect these 2 points with a line. All right, that's the third piece. The fourth piece is x minus 2. Now this is a little more complex, so I'm actually going to make a table for myself. I'm going to make x as one column, then x minus 2 is my next column. And I'm going from 3 to 8. So 3, 4, 5, 6, 7, 8. All right, and I'm just subtracting 2 from every x value. 1, 3, 3. Wait, I thought something was wrong. 4 minus 2 is 2. Last time I checked. 6 minus 2 is 4. 7 minus 2 is 5. 8 minus 2 is 6. All right, so the first point I have is 3, 1. Well, that's the same point as right here, so I'm going to fill that in with a bubble. Next point, 4, 2. Then 5, 3. 6, 4. And I can see here the slope is going up 1 over 1. 7, 5. 8, 6. All right, but when x equals 8, it doesn't, it's not included in this function. So I'm actually going to make that last point an open circle. Great. Yeah, so it's sort of a funky looking function. And we've got one last part. Y is equal to 6 when x is between 8 and 10. So again, if I finish writing my whole axes here, we see that it's going to be equal to 6 all the way across. So I'm going to fill that point in. It's already equal to 6. Then we're going to continue all the way across. Right. So that is right here. That's what that piecewise function is going to look like. And that's sort of interesting, right? It's connected and then it's not connected, but you know, sometimes that's how piecewise functions are. Sometimes all the pieces don't fit perfectly together. All right, next one, g of x. And this will be x, and then I'll quickly label my axes. 1, 2, 3, 6, 7, 8, 10. Should have done this before the video, but hey, what can you do? Hopefully you're all enjoying my handwriting. Hopefully you haven't turned it off. All right, yeah, let's do it this way so we can see the function and see the graph. All right, so this one starts off at y equals 5.5, and it's from -10 to -8. And we don't include the point when x equals -10. So I'm going to go to 5.5 on my y. That's like right here. I'm going to go across to where x equals -10. That's right there. And I'm going to put an open circle right in the middle there. And that's going to continue to be horizontal up until x equals 8. That is inclusive. Connect my dots. That's the end of that piece of the function. Next piece is y equals 4. And that's from -8, not including 8, all the way to -3. So starting at -8, I'm putting an open circle at x equals 4. And that's going all the way to x equals -3. And I'm going to put a closed circle there because we're including the point -3 in that piece of the function. Great. Next, we've got y equals -x, which just means whatever x is, you multiply it by -1 to get y. I'll make a table for that because that could be a little tricky. So let's do x and -x. My x values are from -3 to 2. And sometimes what I like to do, if I see it's not including -3, I put an open circle by -3 to remind myself, and then a closed circle by +2 to also help myself remember. All right, so I'm just flipping it, right? I'm making it positive if it's negative, or negative if it's positive. So this becomes 3, 2, 1, 0, -1, -2. Now I'm just going to plot those points. -3, 3. That's going to be an open circle. Then -2, 2. -1, 1. 0, 0. 1, -1, 2, -2, and that's a closed circle there. I'm going to connect those dots. Great. Next up, we've got y equals -3.5, and that's from 2 to 5. All right, so get to -3.5 here. I start off with an open circle because it doesn't include 2 in its domain. And we're going to go all the way to 5, right here. All right, just connect those 2 points of the line. All right, great. Now we're going to hop over to x is -5 between 5 and 10. I'm going to do the same thing I did in my, whenever I have a function that's just not super straightforward. I'm going to make one column x, one column x minus 5. All right, and my x values are from 5 to 10. All right, we don't include 5 because it's the less than sign. We do include 10. All right, so I'm just going to subtract 5 from all these values. 5 minus 5 is 0, 6 minus 5 is 1, 7 minus 5 is 2, 8 minus 5 is 3, 9 minus 5 is 4, 10 minus 5 is 5. Now I just have to plot these coordinates on my graph. All right, 5, 0, and that's an open circle right there. 6, 1, 7, 2, 8, 3, 9, 4, 10, 5. Great. All right, so that one even looks more interesting. Those are my 6th period class. This reminds me of one of the functions Gage Delgado made. I forget what he compared it to. Like, you ever see those machines where you it drops a ball and then it falls and then goes and then like that? I forget. I'm sure he's gonna remind me. But yeah, this is a very interesting sort of piecewise function. All right, so hopefully you have just an easy time making it from this video. I know it is new, a little bit different, but we can graph each of these functions individually. All we're doing here is saying, I only want this function for this domain. I want this function only for that domain. So it's making sure you can graph all 5 of these and really understand what it means for the domain to exist from -8 to -3, from -3 to 2, what's inclusive and what's exclusive. All right, have a great day.